Alright, in this video we're going to be looking at characteristics of both cube root and square root functions. Now, first of all, the standard form for these types of functions it's given here. A basically will tell you if the parent function has been stretched, a vertical stretch or a vertical shrink, depending on whether it's a fraction or a whole number. If A is bigger than 1, it's got a vertical stretch. If it's between 0 and 1, like 1/2, 1/3, something like that, it's a vertical shrink. If this value is negative, it means it's also a reflection over the x-axis. The H is your horizontal shift. If you have x plus a number, it means it's moving it left that number. If you have x minus a number, it'll move it right that many. And then plus k, k is your vertical shift, you're up and down, so if you add a number, it moves it up that many. If it's subtracting a number, you move it down that many. And you can look at this form and tell what your turning point or ending point is by looking at your h and k value. Now, end point is when it's a square root function. Turning point will be for a cube root function. So just for an example, let's look at these and tell what the transformations are. For this first one, the 2 and the 1 are transformations. Now the 2, it's a horizontal shift, but the horizontal always goes opposite the direction you would think. So that actually makes it go right 2. And this 1 makes it go up 1. So looking here, plus 2 on the inside actually makes it move left 2. This makes it go down 1. On this one, the negative means it's got a reflection over the x-axis, and the minus 3 outside the radical means it moved down 3. Here, there's 2 transformations. The 2 means we have a vertical stretch by a factor of 2. I'm pretty sure I just spelled that wrong. Okay. And then the plus 4 inside the radical, remember the h, that's the horizontal shift, but opposite the direction you would think. So it's going left 4. And then here, 2 transformations. The negative means it's reflecting over the x-axis, and the 1/3 means we have a vertical shrink or vertical compression by a factor of 1/3. Now, there's other characteristics we can get from the graphs too, though. Now, this right here, I can look at this graph and tell what the endpoint is. The endpoint of this graph is -2, -1. Change your sign on the one under the radical, and then what's outside, you just keep it. However, let's say you don't remember that. When you go to graph it, square root of x plus 2 minus 1. When you go to graph it, you can always tell, because eventually you're going to get to a point on a square root function that it basically gives you an error for all your y's. That's because our graph doesn't go past that endpoint right there. Now let's keep this up and look at the other characteristics. Now, for our domain, remember, is your x values. It doesn't go on forever. It has the left side has a boundary to it. That's your endpoint. So all my x's are greater than or equal to -2, because it can, on my x-axis, it can be -2 or any number bigger than that. For my range, remember that's your y values, is any y greater than or equal to -1, because -1 or above is where my graph is. Now for end behavior, the x, that's talking about left or right. The f of x, that's talking about up or down. Okay, so looking at the right side of the graph, this graph goes right forever. Right on the x-axis is positive infinity. At the same time, it's also going up forever. Up on the y-axis is also positive, so that's also positive infinity. On the other side though, on the left side, it doesn't go on forever. It stops at your endpoint. So my x's continue till they get to -2, and my y's continue until they get to -1. Now, increasing and decreasing intervals are another thing you can get for the graph. These are looking at your x values. Now, if I look at this graph and go from left to right, it's going to go up. It increases forever. So it does not have a decreasing interval. For the increasing interval, well, the graph starts where x is -2. And since it can actually be -2, we use straight lines for that bracket. And then it goes right forever. Right on the x-axis is positive, so it goes to positive infinity. But unlike the -2, it actually can't reach infinity, so we close it with the parentheses. Okay. So let's look at another square root function. This one is a reflection. So I can tell by looking that my endpoint will be at +3, 0. You change the sign of the one inside and outside. There wasn't any, so that tells me 0. But again, you can also go here, graph it, and then look at your table, and you can get your endpoint that way as well. Alright, so let's look at the graph. This one is upside down. Now my domain, well, it's still going to the right of the endpoint, so my x's are still greater than or equal to 3. But now because it's going down, my range will be less than or equal to 0 because it's below that point. Now, real quick, I want to make sure I typed it in correctly. Okay. Now, for the end behavior, on the right side of the graph, my x's keep going right forever. But my f of x, the y values, are going down. Down is -infinity on the y-axis. On the other side, though, it doesn't go on forever. It stops at your endpoint. So the x's go to 3 and the y's go to 0. Now for increasing or decreasing, well, if I trace the graph left to right, it's going down. So it does not have an increasing interval. But the decreasing interval starts at our x value of 3. And we use straight lines because it can actually be 3. And it goes to the right forever, so positive infinity. Alright, let's look at a couple of cube root functions. Now for a cube root, okay, so we have, let's see, we have the cube root of x minus 2 plus 1. Now, before looking at the graph, I can tell what my turning point is going to be. Same way as I got my endpoint on the square root functions. My turning point will be at 2, 1. But again, let's say you don't remember that. If you go, you're always going to have 3 points in a line here. The point in the middle, that is, well, that's your turning point. So, looking at the graph, the turning point is right about there. Now, domain and range on this one are both going to be all real numbers because it doesn't have a limit going left to right, and it doesn't have a limit going up or down. For my end behavior, well, as it goes right forever, so that's positive infinity. It's also going up on that side, up forever, that's positive infinity. On this side, it's going left forever, left on the x-axis is negative infinity. And then going down forever, well, down is negative. So it's going forever down, negative infinity. Now, increasing or decreasing, same as before, if I trace the graph going left to right, it increases the entire time, so it does not have a decreasing interval. Now, because this graph never really ends, the starting point we would have to say would be somewhere in negative infinity. Now remember, the reason it's negative infinity is because we are looking at the x values, the range of x values, where it increases or decreases. And since it doesn't really have a starting point, it's just off on the left where our negative x's are. And they'll continue to the right forever. Right on the x-axis is positive, so positive infinity is where it's going to. Now, next example, negative 1/2 cube root of x. Now, if we go and look at the table, it's kind of harder to tell where your turning point is unless you pay attention here. Here my turning point is going to be the point 0, 0. But let's take a look at the graph and show you another way you can kind of tell. If you look at this graph, you can tell it kind of changes right about there. And if you look, that's about where x was 0, and you can see that it is about the same on either side. So it fits. Now, back to the graph. Left and right, it has no limit, so domain is all real numbers. Up and down has no limit, so the range is also all real numbers. For our end behavior, again, I usually start on the right side. It's going right and down. Right is positive, down is negative. And it goes on forever, so it's infinity. On the other side, it's going left and up. Left is negative, up is positive. For increasing or decreasing, if I go left to right, the entire time, left to right, it's going down, so it does not have an increasing interval, but it is decreasing. Now, because this graph goes left and right forever, it doesn't really have a starting point, so it starts somewhere off on the left and goes somewhere off to the right. Negative infinity to positive infinity. Now remember, we can't actually reach infinity, so we use parentheses around it. Alright, so that's it for characteristics of radical functions.